The underlying OS was Microsoft Windows Server 2008 R2, standard Hyper-V configuration. The virtual machines, the VDIs ran as virtual machines within that environment. In this case, the DataCore SANsymphony-V software ran at operating system level, but it made no difference if we ran it as a virtual machine in its own right. The results were exactly the same. The system was configured this way just so we could have more visibility into what was going on with SANsymphony-V without an additional level of indirection. The disk drives were, the application drives were taken by SANsymphony-V. They were carved up into LUNs. The LUNs were snapshots of a single OS operating system golden image that came from Windows 7. They were then parceled out to the VDIs and booted off them. Those are DataCore snapshots, not Microsoft snapshots, readable, writable. They fail over to the other node if a storage failure should occur. But they're pretty standard differential drives every other way. We used very little storage for the entire system, much less than the storage we configured for the benchmark. We configured 4 SATA drives for the SATA benchmark per node. Probably could have lived with 3, and that included mirrors from the other side coming in. Sure I can. It's interesting. Put a bunch of machines together in one machine, create a machine of machines, and all of a sudden you start to have opportunities for shared resource and shared activity. I mean, this is as old as the hills, right? It turns out that some of this stuff just works this way naturally. So, for example, we went to differential snapshots as the boot devices of these virtual desktops. We were afraid that virtual snapshots wouldn't scale. The opposite turns out to be true. Turns out that by going to snapshotting, the golden image from which all snapshots started almost was always in cache. Never moved, right? And so there were times when the disk lights weren't even coming on with 120 guys doing real work. This is sort of expected, and retrospectively it's totally understandable, but it is a little counterintuitive in that you tend to see things like differential disks as imposing an overhead, right? Memory, same story. We found that the working set for desktops, as many people have found before, are quite small, smaller than you'd guess, and that as a result, when it was a common working set that was being cached fairly routinely, right, you started to get diminishing returns pretty rapidly, right? Now, we defined a block cache, which is really the secret to this performance here, at a size of about 4 gigs, right? That was really only to absorb the boot storm and the anomalies at the edges of the virtual desktop application. The actual working set for operating desktops running a range, I mean the VSI range of desktop applications, was less than half of that, right? So you got tremendous results with very little memory. And you got more with more memory, but not a lot more. We saw no real advantages to 2 gigabyte memory allocations for the desktops. You know, whether we overloaded them or not was immaterial. We didn't do that because we wanted comparability to what had been published previously. But in general, the memory games were mostly not necessary. The one that was really interesting was that we found that it was practical to thrash machines because everything was in cache. So this is just another variation on a second level of virtual memory and what the hypervisor vendors were doing. But we found in our cases that we could create discrete virtual desktops that as PCs would never have booted. You know, 128 meg Windows 7s. The reason that works is because it's a 128 meg memory model machine that is paging to a 4 gigabyte always in RAM disk. As long as everybody isn't paging at the same time, it's completely practical. So there's opportunities here in the shared environment that we've created. And it's our fault if we didn't see them ahead of time, but retrospectively they're kind of obvious, you know. So this technology has a lot of interesting sidelights to it in the future.